Okay, before we start, I'd just like to confirm that you guys can hear me and see me as well and see my screen. Sorry, let me allow chat, then you guys will be able to tell me. So please just tell me if you can hear me, see me, and hear my screen. Then we can begin. So that's on YouTube. YouTube question, which group are you currently in? Hello, can you guys hear me? Okay, cool. I think you guys can hear me. Okay, let's go on. Okay, so perfect. Thank you. Okay, so assalamu alaikum and welcome. Good afternoon, everyone. Welcome to the extra grade 12 maths class by Inspired Teens. So yeah, for those of you who joined the first one or at least watched the first one, you'll know a gist of what's it about. Okay, so what I want to start off by is just going through two sequence and series questions to end on that topic. And yes, we will be doing many questions, right? As I've been saying with these extra lessons, right? So today we'll do these questions. We'll start some functions. Okay, we are still going to do functions on Saturday. So for those who don't join this, I'm not going to be behind, but we won't waste time in getting into questions. We're just going to, instead of like when we do a certain topic, we're going to try and complete it and then go into questions. Okay, so I'm going to teach you guys faster, right? And then when we go back to the Saturday lesson, it's important to still join it because we will still be covering certain things there. And maybe we might repeat one or two things and it will be like revision for you guys, right? And we'll be doing different questions. Okay, let's have a look at this strange question. Okay, so again, we're just going to be doing two questions from sequences and series to end that. And we're actually going to be starting functions and hopefully we can get to a question, right? Okay. Again, I'm sure you guys know, but please remember that if you have any questions, right, feel free to ask it in the chat, the Q&A, or the YouTube chat. And please note that this document will be sent to you guys after this lesson. Okay, cool. So it says use the sum to infinity to write 0,4 recurring. So remember, 0,4 recurring just means that the 4 continues forever and ever and ever. 0,4, 4, 4, 4, 4, and so on and so forth as a proper fraction. Okay, so this is a bit of a challenging question. It might, yeah, okay, it's obviously with challenging questions in your examination, there's a chance that a few questions can be challenging. If you've done the past few November examinations, you'll notice like there are quite a lot of difficult questions, right? Okay, so let's go through this question. And it might seem complicated, but it's actually quite simple once you understand it in terms of sequences and series. Use the sum to infinity to write 0,4 as a proper fraction. So first, what we're going to do is we're going to express 0,4 recurring, okay, as a pattern, okay? So 0,4 recurring, remember, is 0,4, okay, plus 0,04 plus, okay, when we add it all up, it basically gives us that 0,004 plus 0,0004 and so on, right? All of these add up to give us 0,4. Okay. Also, another thing for this lesson is we're going to try and find a way to contact with you guys the best way. If you guys have any specific questions, then we can go through questions that you guys have as well. All right. So keep that in mind. Okay. So yes, this is it written as a sum pattern. Okay. So remember, the sum to infinity can be written as a over 1 minus r. Okay. So we can actually get r for this pattern. R is actually equal to T2 over T1 or T3 over T2 and so on. So in my case, my second term is 0,04 and my first term is 0,4. Okay, when you simplify this fraction, you get 0,1. So we know that r is equal to 0,1. So we know the value of r. We know the value of a is 0,4. So now we can use sum to infinity to write 0,4 as a proper fraction. So the sum to infinity for this pattern is 0,4 recurring, by the way, is equal to a is 0,4. Okay, 1 minus 0,1, which can be written as 0,4 over 0,9, which is basically 4 over 9. Okay, we know why do we use sum to infinity? Because remember, 0,4 recurring has 4 decimals continuously forever. Okay, so in that case, yes, we use sum to infinity. So we've used sum to infinity to basically show it as a proper fraction, because we calculated the sum to infinity for its pattern. Okay. Okay, so a tricky question that makes you think. Let's move on to the next one. So this one is not so challenging. Someone actually asked me this question. So we can just go through it, okay? We did examples for variables with arithmetic and geometric. We didn't do for one with quadratic, okay? So it says determine the value of x if the following quadratic sequence is given. Okay, we can even calculate the Tn if we'd like. Could you please send me to the main group? When you say main group, what group are you currently in? Are you not in any group? Okay. Currently, it's tough to add people to the group because the community is full. So it's difficult, like there's no space in certain groups. So if you're out of the main group, yeah, I sent you a link that you can use to join. Okay, are you in any group though? Okay, so in this specific case, we're going to follow the same concept, right? Okay. Okay, so in this case, like remember for like arithmetic, whenever we worked with variables, the first thing that should come to mind is we should try doing T2 minus T1. When it came to geometric, right, the first thing that we should try to do is T2 over T1. Okay, in this case, it would be equal to T3 minus T2. And for geometric, we do, it's equal to T3 over T2. Right, so that's for arithmetic and geometric respectively. So we use the similar concept in quadratic, okay? Because remember, so quadratic, we can't technically do the first one only because we don't just have a first difference, we have a second difference as well. So let's find the first differences. The first difference here is x plus 3 minus 5. We can simplify it in a bit. And we have 13 minus, open brackets, x plus 3. Okay. Then we basically have the last one, which is 4 minus 13. Okay, so let's simplify each one, then we can actually write its value. Okay, so this one simplifies to x minus 2. This one simplifies to 10 minus x. And this stays as 14x minus 3. So, maybe what we can do is write it a bit bigger. X minus 2, right? This becomes 10 minus x. Wait, no, this is wrong. Sorry. It's 13. Oh, no, it's right. It's right. Okay, it becomes 10 minus x, and this becomes 4x minus 13. Okay, so this is our layer of first differences, remember, right? This is our layer of first differences. So we're utilizing that same concept either way. Now we need to express our second differences. So let's do just that. There's going to be 10 minus x minus x minus 2. And this is going to be 4x minus 13 minus 10 minus x. Okay, so Now, one thing to note. Okay, please message me, Nancy. Message me and I will try to add you to the group. Alternatively, I will send you a link. Okay, I will send you the links that you can use every week. So one thing is important to note is these are our second differences. Okay, now remember our second differences are actually common, meaning they are equal. So what we can do is we can take this second difference and equate it to that second difference. Why? Because we know that the second differences are equal in value. So let's do exactly that. 10 minus x, I'm going to distribute the negative. Minus x plus 2 is equal to 4x minus 13 minus 10 plus x, right? So what we can do is get all the x's on one side. Negative 2x minus 4x minus x is equal to negative 23 minus 10 minus 2. So here we get minus 6 minus 7x. Here we get minus 33 minus 35. Can divide both sides by negative 7. And x should be equal to positive 5, I believe. Okay, so this is another example. This is a quadratic with variables. Okay, so again, you're keeping the same concept in mind of subtracting the two because of differences, right? So in this case, you need to just know what the difference is between each term. In arithmetic, it's a first common difference, a regular common difference. In geometric, it is a constant ratio, okay? While in quadratic, it's a first difference, which is not common, so it's not equal. However, there's a second difference, which is equal, so we can utilize that to create an equation by equating one second difference to another second difference. Even if you had a third one, you could equate it to that as well. Okay, so quadratic. All right, let's move over. Okay, so again, we are going to repeat this on Saturday, right? We're just going to get started and try and at least do a question. Okay, just so, again, it's a bit of a weird time to start these classes, these extra classes, just because we haven't started a new topic. We sort of we're ending that topic. Okay, so for the next few topics, it should be a lot more structured and we're doing the topic that we're currently doing or the work that we're currently doing, just extra. Okay, so firstly, I want to talk about a straight line. Okay, so when we talk about functions, okay, a lot of people struggle with functions, different aspects of functions. So we're going to start from the basics, which is the function of a straight line. Function of a straight line. Let's get rid of this. So the function of a straight line, its formula, its general formula, okay, is y is equal to mx plus c. I'm sure we all know this, where c is our y-intercept. Okay, what is a y-intercept? A y-intercept, we'll go through it in a diagram. We can do it here actually. On a Cartesian plane, all right? We have a little Cartesian plane here. On a Cartesian plane, you have an x-axis and a y-axis, a vertical y-axis and a horizontal x-axis, a vertical y-axis and a horizontal x-axis. Now, we can have any function, okay? A function is created when we plot coordinates on a graph, okay? When we have an input and an output. So basically, let's look at a straight line function, okay? It's, as the word says, it is a straight line. Surprise, surprise. Okay, and here, the point of the graph, which touches the y-axis, that is what we call the y-intercept. Okay, the point of the graph, right, that touches the x-axis. So here we have the y-intercept. Point of the graph that touches the x-axis. This is the x-intercept. It is where the graph intersects or intercepts with the x-axis, or alternatively, the y-axis. Okay, so that's what we mean when we say y-intercept. That's what we are talking about. Okay, now, okay, we learn its coordinates as well. So x and y, okay, are coordinates that you plot on a graph. For example, in our Cartesian plane, we have 1, 2, 3. 1, 2, 3. Okay, so plotting coordinates, you're going to plot a y value and an x value. So you're going to plot, for example, 2 and 3. Okay, it creates a coordinate here. Okay, and you put the x coordinate first and the y coordinate second, and that represents that specific coordinate. I can give a name to it or a label. I can call it A, and I'll call that coordinate A. Coordinates A are plotted on this Cartesian plane with the values 3 for x on the x-axis, okay, and the values 2 for y on the y-axis. And where those two meet, they create a coordinate, okay, important. So when you talk about x and y in your equations, in your general equations, right, you are talking about values that could be substituted, okay, values that are changing. Okay, I could substitute a value for x, I'd get a certain value for y. I could substitute a value for y, I'd get a certain value for x. Okay, however, then we have m, which m is the gradient. Okay, and once you calculate this, this doesn't change for the formula. So the gradient is m, its symbol is m. There is a formula that we can utilize to calculate gradient. It is y2 minus y1 over x2 minus x1. I'm sure most of you know this formula, right? You've been doing it for years. Then we have c, which again we said is the y-intercept. So m and c, okay, are values that you need to solve for in order to have your equation, okay? X and y, if you put a value for x, you're going to get a value for y. If you put a value for y, you're going to get a value for x. Okay, so these are important key things to note in a straight graph. Now, we have two types of straight graphs. The one we currently drew, okay, let's just say this is doesn't really matter, but y is equal to x plus 1. Let's change it to okay, so this would be an example of this type of graph. Notice that m is positive. Okay, and since m is positive, it's an increasing function. When m is positive, it's an increasing function, right? How do we know that something is increasing? We know that something is increasing because when we look from left to right, okay, we'll go through this when we do intervals as well. When we are looking from left to right, so always start on the left, right? If you have to picture a little guy on the most left part of your drawing, okay? When this little guy is moving from left to right, is he moving up or is he moving down? Okay, does it look like he's going to take a staircase up or does it look like he's going to use a slide going down? Okay, so in this case specifically, we can see that when we work from left to right, we can see that that this graph is increasing because from left to right, we can see that it's moving up in values. So basically the y values are increasing. Okay, it's noted somewhere in these notes, we will go through it. But yes, the y values are increasing as we go from left to right, as you can see. There it's maybe -4, -3, -2, and so on, right? Going all the way up. So from left to right, from left to right, the y values are increasing. Alternatively, look from left to right and see, would you have to climb up or would you have to slide down? So let's look at its opposite. Maybe look something like that. This perhaps is y is equal to -2x plus 1. So what does that little negative indicate? It indicates, okay, sorry, plus 1. It indicates to us that the gradient is negative. Indicates to us that the gradient is negative. So basically, if m is less than 0, remember m is gradient, okay, we have actually a decreasing function. So if this dude had to be on top, okay, he would fall down to his death. Not really, but yes, you'd be like sliding down. Okay, so that's the easiest way where you can tell something is increasing or decreasing. All right, let's just see if there's anything we haven't talked about. Okay, y2 minus y1 over x minus x1. Of course, you have done plenty of examples up until now, and we will, of course, go through plenty of examples of gradient. Okay, but you need not forget that formula. Obviously, it's not a formula. Is it given? It might be given. I think it might be given in the formula sheet, but nevertheless, I'm sure many of you know it. Okay, so just keep in mind for this section, because obviously we do parabola as well, that we can either work with gradient, okay, or average gradient. Okay, we'll go through that basically when we go through parabola, but it's when a function doesn't have a constant gradient. So if we look at this, right, the gradient or the slope or the incline is constant, right? It doesn't change. It's a high, an increasing gradient, okay, with no change in it. However, sometimes you do get gradients that are changing. So when we say, that's why we say average gradient, okay, because it's constantly changing and we basically add them all up and blah, blah, we get the average gradient between two different points, okay. We'll go through an example, but please just note that the gradient and average gradient both utilize that same formula, okay, which is basically the gradient between 2 points, okay. I think that's about it. Let's move on. Okay, so something that's also equally as important that you have to understand, right? Many people don't understand this and they confuse it, and it causes a lot of issues because they ask a lot of questions relating to it. Okay, so you need to understand it. The better you understand it, obviously, the better it is for the harder questions. Okay, they might seem simple now when they're in one diagram. Okay, but when it's combined and when you have difficult questions, that's when it can get confusing. Let's talk about the equation of a vertical line. The equation of a vertical line. First, before we do that, we're going to just quickly talk about gradient. Okay, so one thing you should note is that the gradient of a horizontal line, can anybody tell me what is the gradient of a horizontal line? What is the gradient of a horizontal line? Anyone? Gradient of horizontal line. How we all just tired. Are we all just sleepy? No one? Not a single soul? Yes? A guess? Any guesses? Okay, it's fine. I gave the answer on the thing, sorry, but yeah, it's on the thing, but either way, okay, it's 0. Yes, the gradient of a horizontal line is 0. Okay, so when we think of gradient, okay, and we define gradient is basically like slope. Okay, someone said 1 is incorrect. We have zeros. Okay, 0 is indeed correct, right? When we talk about gradient, we talk about slope. Okay, we talk about how steep is something. Okay, how much of an incline a hill has, how slanted something is, whatever. All right, all refer to gradient. Okay, so in this case, yes, gradient of a horizontal line is 0. It is a flat surface, right? There is no incline on a horizontal line. So therefore, its gradient is 0. If you had to put, let's just say, for example, a car. Okay, it's not moving anywhere, right? Because the gradient is 0. Any object for that matter, I'm just saying. It's a completely flat surface, okay? Then as we go up, perhaps we have, maybe this is a gradient of 1. Okay, maybe this is a gradient of 3. Too big. Okay, maybe this is a gradient of 3. Then maybe this is a gradient of, I don't know, 5, whatever. Then we can talk about a straight line. Okay, maybe we go more and more up. Basically, when you go more and up, it increases. Maybe this is 20, I don't know, right? Now, could someone tell me what is the equation of a vertical line? So when I reach the perfect vertical line, what is the, sorry, not the equation, what is the gradient of my vertical line? Anyone? The gradient of the vertical line. Okay, 0. No, it's not 0. 1, it's not 1. Unidentified, 1, 0. Okay, we specify it as undefined. Okay, because the reason is, okay, we can have a look in this diagram, right? As we're increasing our slope, we're going from 1 to 3 to 5 to 20. Then when we go perfectly vertical, what is it supposed to be? Is it supposed to be 30 because it's more than 20? Is it supposed to be 500? Is it supposed to be 1,000,000? Okay, that's in that case just because it is going straight up, right? We cannot define its gradient. So yes, indeed, it is undefined. So the gradient of a vertical line is undefined. Okay, so those are two important things to remember: the gradient of a vertical line and the gradient of a horizontal line. So when you talk about the equation y is equal to mx plus c, this gradient is right there as m. Okay, so since the gradient is right there as m, if we substitute under, can you substitute undefined? You can't substitute, oh, undefined times x. No, it doesn't work like that. So in that case, the y is equal to mx plus c formula, okay, it doesn't really apply, it does, but no, it doesn't exactly follow y is equal to mx plus c, and that's not the way we should remember it, just because the gradient is undefined. So again, you can't substitute an undefined into this formula, okay? So in that case, it will have its own formula, we'll learn it. What about a horizontal line? A horizontal line has a gradient of 0. So basically, it makes this entire thing 0. And eventually y is equal to c. That will be the equation. The equation of a horizontal line is y is equal to c. Okay, c, remember, is our y-intercept. Okay. So let's have a look at the equations. Right. So the equation of a vertical line, okay, is x is equal to its x-intercept. X, okay, it does not follow y is equal to mx plus c, again, because we just showed that, okay, this guy has undefined gradient, okay, so in that case, since it has undefined gradient, I cannot put it into the formula y is equal to mx plus c, okay. However, I can simply say that x is equal to the x-intercept. Please remember the x-intercept can be, it doesn't have to just be the x-intercept, right? I'll show you why, because let's just say this x-intercept is -3. Since this x-intercept is -3, remember, this is a vertical line, so any point along this line, the x value is going to be 3, -3, sorry. Okay, this will be a negative y value. Okay, so if you have the value of any, if you have any x value on a vertical line, you basically have the formula. You need to say that that formula is x is equal to, sorry, x is equal to the x-intercept. Okay, I hope that makes sense. So again, it's extremely important because we deal with equations of vertical lines, and some people, maybe it's too easy for them to remember, or they just forget about this and forget its concepts. Let's talk about a equation of a horizontal line. So let's just say this horizontal line cuts this y-axis at 4. Remember, we said that the horizontal line is equal to c. C is the y-intercept. So basically, it's going to be y is equal to 4. So again, with a horizontal line, it's y is equal to y-intercept as our formula. And again, any point on the graph, any point on this graph would return 4 as the y value. So here, right, this coordinate could be positive x value and 4 as the y value. Okay. Similarly, on the other side, this coordinate would read a negative x value. Sorry, I can just leave it there. Thank you. A negative x value and 4 as well. Okay. So two things to note. Okay. Firstly, we are learning the, what is it? The formula of a vertical line. Okay. As well as we need to be able to understand that the x value on a vertical line remains constant. Okay. X value on a vertical line remains constant. And with a horizontal line, we learned the equation of a horizontal line. Y is equal to the y-intercept. Okay. Or for that matter, any y value on that line is going to be the same as the y-intercept. It's a vertical line. It carries over its y value. Okay. So in this case, whatever coordinate we have on any point on this line, it returns the y value of 4, positive 4 in this specific case. Okay. And again, y is equal to the y-intercept. Let's just do a quick exercise to reinforce that. How do we do this? We have a coordinate. Okay, it's fine nevertheless, right? Just say we know this coordinate is going to be 5 and 0. And we know that this coordinate is going to be 0 and 6. Okay, so we can see that the third point, which I'm going to color in green so that we can see it nicely. Okay, the third point, firstly, it is in line with this coordinate. So let's label it, right? Let's call this guy A. Let's call that B. Let's call that C. We can see that B is in line with C vertically. Since it's in line with C vertically, right? Remember the X point originates from there, right? That's the lowest it can be. Yeah, it's 0. And then any value on the vertical line has the same X value. So therefore, we know that this guy is actually going to be 5. Thereafter, it is also lined up with this coordinate. Okay, and this coordinate, because it comes from the y-axis, it's giving us the y coordinate of this point number B. And it's going to be 6. Okay, we can join the two. That's always important to know. Okay, let's move on. Forgetting anything? I don't think so. Okay, transformations we'll come back to. Right, let's start with parabola. Okay, so we have another function which we're learning next. Okay, first of which is straight line, and then now the second is parabola. Parabola, I think we've been learning it for a good few years. So let's do the revisions of the basics of parabola. Okay, so again, for these classes, like for example, a section like functions. I think I said that right. There are ample questions we can practice. Okay, like different types of variables are given. Okay, different form. It's given in a different form. It's given in standard form. It's given in turning point form. It's given in root form. With one is like a forward question, one is backwards, where everything is a variable. Okay, so we can get those all done in this lesson. All right, so again, it's just another example of how this could benefit you. Okay, so let's talk about parabola. Okay, so the first form which we're going to learn is standard form over here. Now, standard form, okay, has a standard equation, the general equation for standard form. It is y is equal to ax squared plus bx plus c. Okay, y is equal to ax squared plus bx plus c, where c is our y-intercept. Again, just like in straight line, how c is the y-intercept, here we have in standard form parabola, c is the y-intercept as well. Okay, then we have in the standard form, okay, in order to calculate the turning points. Okay, let's revise what a parabola looks like again. So here's my axis, right? Remember, my parabola is either the sad face graph or the smiley face graph. So it's like a curve, okay, a single curve. So we have a turning point, okay? A turning point on a parabola graph is the point at which it goes from decreasing, in this case, because remember, if I put my little guy there, from left to right, he's going to slide down, hey, until he gets here. Once he gets there, then he's going to start climbing up, okay? So again, when he's climbing up, it's increasing. When he's climbing down, it's decreasing. Okay, please note that. Don't confuse it. Okay, so it actually it changes at the turning point, which is important for us to know. We'll go through it, like we'll have notes for that, and it's important for us to understand that when we do intervals. Okay, but in general, of course, as well. So it turns at a turning point. So that's what our turning point is. This basically this point that I created here at the bottom, the point at which the graph changes from decreasing to increasing. That's known as the turning point. So the turning point coordinates can be calculated using these formulas when standard form is given. So turning point x is equal to negative b over 2a. When we say negative b, we're talking about this b, the coefficient of x. 2a, we're talking about that a, which is the coefficient of x squared. All right. Then to get the turning point y, once you have solved, so you solve for the turning point x first. Once you have solved for turning point x, you substitute that x value into the equation to get the turning point y value. Okay. We of course eventually get to an example. Now, it's very important to talk about how to calculate the x-intercept. It is simple. You need to make the value for y 0. And how do you get the y-intercept? You need to make the value for x 0. Okay. Right. Let's talk about turning point form. Okay. So turning point form, y is equal to a, open brackets, x minus p squared plus q. Okay. So slightly different. Okay, but we still have a parabola, we still have a quadratic equation in essence. Okay, and in this case, we have two variables. So firstly, right, remember we spoke about x and y. X and y, okay, always remain in our formula because these are values that we can substitute from the graph. Coordinates like x coordinates, y coordinates, corresponding ones that we can substitute from the graph. Okay, so we always want those in our formulas. So x and y, they're technically not unknowns, right? Because we substitute them with coordinates. Now the two are p and q. Okay, so p is basically the actual value of the turning point. Let's not do that. Why? Because it's not just any turning point. It's the turning point x. It's the x coordinate for turning point. Okay. And that makes q then the y turning point. Okay. TP turning point. Okay. A difference between the two, however, is when you, okay, when you need to plot their coordinates, you need to note that you will use the opposite sign for P. Okay, we'll go through an example. And Q, you will utilize the same sign, and that's the turning point. So in this case, if turning point is, so they're giving us the coordinates of the turning point, -3 and -4, then the equation is as follows. So in this case, we have y is equal to, we're going to write it in what is known as turning point form, because turning point form is the form in which the equation is written with the turning point. So we have y is equal to a, open brackets, x minus p. Okay, it's the turning point. X is what we substitute into there, and it is the opposite sign. Okay, meaning, for example, in this question here, in that equation, we have a, open brackets, x minus p squared plus q. In the specific case, if it was minus p, the actual turning point would be p. And for q, because we use the same sign, we use positive q. Okay, so in this case, remember, opposite sign. If you're going from turning point to equation, opposite sign. If you're going from equation to turning point, opposite sign as well. So a is equal to, sorry, y is equal to a into open brackets, x plus 3 squared minus 4. So I changed the sign for the xTP, and I kept the sign for the yTP. Okay, I hope that makes sense. So just give me 1 second. I just need to switch on my light. Okay, so I hope that makes sense. Turning point form, all right? Opposite sign. Always keep that in mind. Whenever you're substituting, all right, keep in mind, you can go from having the turning points to get to the formula, or they could require you to understand and identify that from the turning point formula that's given, you need to know the coordinates of the turning point. Okay. Then we have, so in turning point form, right? How do you calculate the turning point? Right? Obviously, in turning point form, there's no formula to calculate the turning point because it's given in the question. Okay, so that's that. Now, when it comes to x-intercepts and y-intercepts, same thing. To get the x-intercept, make y 0. To get the y-intercept, make x 0. Let's just discuss this quickly. If I had to quickly draw a straight line. Okay, now let's call this x, let's call this y. That's 1, that's 2, that's 3. 1, 2, 3. So at origin, we can agree that both coordinates are 0. Okay. What about if we stay on one of the axes? Okay. So here, both are 0. Okay. But what about if I shift over 1 unit to the right and my coordinate is on the x-axis? In that case, right, I am so wrong. Okay. In that case, right, when I shifted 1 over, the x coordinate has shifted. Definitely, the x coordinate has increased. But since we haven't moved up or down from 0, from origin, we haven't changed the y value from 0. So in this case, this coordinate has a y value of 0. X coordinate of 1, y value of 0. Let's talk about a coordinate here. Okay, so here we moved 3 units up. 1, 2, 3, but we didn't move to the left or to the right. Okay, in that case, by the way, here we didn't move up or down. Okay, but here we didn't move to the left or to the right. So we have a y value, however, because it didn't move left or right, the x value is 0. So here my coordinate is 0 and 3. Now, as you can see, that any point on the x-axis, okay, has a y coordinate of 0. Any point that lies on the x-axis has a y coordinate of 0 because it hasn't shifted up or down. So it cannot have a y coordinate as anything except 0. So this is the exact reason why, in order to calculate the y-intercept, you need to substitute x as 0 because the coordinate will be 0 and x. I mean 0 and 0 and y, sorry. Okay. For y-intercept, 0 and y, in this case 0 and 3. So the y-intercept here is 3. Again, this is where whatever graph we're working with, whatever it is, this is where that specific graph cuts the x-axis and the y-axis. Okay, so similarly with the x-axis, you make y 0. Why do you make y 0? Because remember, when we cross the x-axis like we did here, at this specific point, that part of the graph is not above 0 nor below 0 in terms of y. So in that case, we make y 0. Okay, so this is a simple explanation of that. Let's talk about root form. Okay, so root form is y is equal to a open brackets x minus x1. Okay, x minus x2. Okay, so root form. Now, when we talk about roots, so turning points TP, turning points, when we talk about roots, we could also call this x-intercept form. The reason is because a root is an x-intercept. They are one and the same thing. An x-intercept again is a line that crosses the x-axis. All right. So things to note about this. Okay. So this is x-intercept 1. This value for x1 in the equation. And this is the value for x-intercept 2. All right. And we need to note that they are both opposite signs. It's important. Whatever it is in the graph, you're actually going to put the opposite sign for the equation. Whatever it is in the equation, you're going to put the opposite side for the graph, opposite side, sorry. Okay, so just say we have this example. This is a nice graph for root form because we are given both roots or both x-intercepts, right? So we can write it out. So y is equal to, we don't figure out that a, okay? Y is equal to a, open brackets, x plus 1, x minus 2. So can we see what I mean by opposite signs? Whatever sign it is in the graph, it's the opposite in the equation and vice versa. Okay, so with root form, it is opposite as well. Axis of symmetry is the XTP coordinate. Okay, this is really important and they utilize it quite a lot. Okay, so as you can see, I'm taking my time to go through the basics, okay, because these basics are important and the fundamentals for the harder stuff. And a lot of these basics, maybe we underestimate them or whatever, but we really need to know them well if we want to do well functions. So axis of symmetry is the XTP coordinate. So if we have to look at this parabola graph, we can see that there's a turning point, okay, somewhere between -4 and 1. We know that for a fact, and it's somewhere below the x-axis. Basically, here, right, at some point here, turning point. Okay, that's where it's drawn. It's again where the graph turns from decreasing to increasing in this case. Now, the point, the x coordinate of that point, the x coordinate of that turning point actually creates a vertical line of symmetry. Okay, so remember symmetry, if you ever did it in lower grades, they used to make you fold those papers and then the lines would touch whatever it is. So similarly, in this case, if you had to fold the paper along this line, these lines would touch one another. Okay, symmetrical. Right, now, in that specific case, right, let's discuss this axis of symmetry. Okay, we actually did. So we're just confirming that it is an axis of symmetry. That's what you need to understand. It creates symmetry between the two. If you fold it, it'll touch each other and so on. So why is that important? We'll get to that in a bit. Also, x turning point is the midpoint of the x-intercept. So this is just as important, right? Both concepts work hand in hand. First of which is axis of symmetry. The second one is that the x turning point is the midpoint of the x-intercepts, always. Okay, where the graph intercepts the x-axis, it's actually the x turning point is actually its midpoint. Okay, so we can look at this diagram and we can see that firstly we have the dotted line. The dotted line is created for XTP as it's a line of symmetry. Then we have one x-intercept, other x-intercept. So what we can do is we can utilize this formula. We can get the midpoint of x-intercept 1 and x-intercept 2, and we will get the x coordinate of the turning point. It's that simple. So midpoint formula is x plus x1 plus x2 over 2, and I mean, yeah, x1 plus x2 over 2, and y1 plus, here's it here, sorry. Okay, we're not going to do y, we're just going to do x because we're finding midpoint of the x coordinates. So here is it here, x1 plus x2 over 2, that's going to give us the xTP. Okay, so it's an easy way to calculate it. And remember, so -4 plus 1 over 2 is equal to -3 over 2. So this xTP here is an x coordinate of -3 over 2 and some negative y coordinate, right? Okay, so yes, two things. Axis of symmetry is created by the x turning point coordinate when you draw a vertical line through it. X turning point is the midpoint of each root or each x intercept, right? Okay. Okay, so this drawing graph, I'm going to leave it for Saturday. What I do want to do, however, is this question, right? So I know we haven't done much yet, but my guess is firstly, you have experience with parabola. Secondly, most of you might have started parabola either way. So it's safe to assume that you know the basics, right? We're doing a revision of the basics either way. But let's have a look through this question, right? Which is basically a slightly more challenging question, right? It's not so straightforward as here's the function, draw the graph. Okay, determine x-intercepts, determine y-intercepts, determine turning points, and so on. Okay, so it says the graph of f of x is equal to a, open brackets, x minus p squared plus q, where a, q, and p are constants. Okay, so basically they're the constant number. Points E, F, 1 and 0, and C are the intercepts with the coordinates axes. So again, I'm going to repeat this, right? For maths, for physics, whichever you take, if you take both, or if you take one, what is important to note is whenever you're reading the question, firstly, you need to read the question. Never ever skip the question and go straight to, okay, when I'm saying question, I mean the paragraph introduction, the paragraph top of the question. They'll give you an explanation, they give you a brief, they give you a paragraph of information. Okay, and there's a lot of information there. That information is important. Some of it, most of the time, is crucial to you answering the question. So if you're gonna skip it and then come back when you're in a question one already and then trying to piece information to see what's going to help you, it's not going to work. You need to read the entire question. You need to understand what's going on in the diagram. The next step is that whenever you see something whenever you're reading the information paragraph, all that information you need to make sure is in the diagram. Why? Because look, when we are solving a question using a parabola graph, it's much easier to see it on the graph. Okay, instead of giving statements like, okay, the x-intercept is this, then you can't solve it in your head. When you have a physical graph in front of you, it's much easier to see, to visualize, and then solve. So therefore, all the information in any question, whether it's in physics, vertical projectile motion, whether in maths, it's calculus, number patterns, you need to read the question and make sure, okay, not number patterns, anything with a diagram. You need to make sure that all those things that are in the question are in your diagram. So you don't have to go back to the question. Okay, maybe you will, maybe you won't have to, but the least that you have to read in the question, or even highlight it if you'd like. Okay, I noticed that highlighting is really good, especially when you pushed for time. Okay, because so when you pushed for time and you're coming back to this question and you see the key things are highlighted, okay, you don't really worry about everything else that's like in black and white. That's not important, right? Your brain will focus on what's highlighted and be like, okay, E and F and blah, blah, blah. You have 5 minutes left and maybe you'll be able to solve it, right? It's definitely going to help you if you just have to look at the highlighted stuff. Okay, they are its intercepts on the coordinate axis. Okay, so let's have a look at them in the diagram. So they say that E, F, and C, we have E, F, and C. Okay, it's definitely going to be true, but you double check it, right? Intercepts, so they don't specify which intercepts, so it could be Y or X, so that's perfectly fine. F's coordinates are known, okay? So F's coordinates have been put in the diagram for us, so that's fine. We don't have to put it, right? And we know the intercepts, cool. We know that E and F are X intercepts and C is this Y intercept, right? What the coordinates axis, A is -4 and 5, okay? So A is here, the intersection between those two graphs, okay? We'll get to that as well, how like we need to make sure we see the relationships, but anyway. So yes, A is -4 and 5, its coordinates are in the graph, so that's fine. Is a reflection, so the coordinates A, -4 and 5 is a reflection of C across the axis of symmetry, right? So that's a bit of a confusing part, which we'll go through. D is a point on the graph such that the straight line goes through A and D and has the equation -2x minus 3. So we can clearly see that D is another intersection point between these graphs. So therefore, we know that this graph G of x, which is the straight line, passes through this parabola, okay, twice, okay? So firstly, intercepts done, A done. A is the reflection of C across the axis of symmetry. Firstly, I draw my axis of symmetry. It's something like this by my turning point. Okay, just a quick note. They say that C is the reflection of A about the symmetry, axis of symmetry. C is a reflection of A about the axis of symmetry line. So in that case, could someone tell me then, because the first question is right on the coordinates of C, could someone tell me then what would the coordinates of C be? Or anything you know about C, just given that information. Okay. Stating that C is the reflection of A about the y is equal to, sorry, not y is equal to, about the axis of symmetry line. Anyone, what is the coordinates of C, given that information? Okay, we have 0 and 5. Okay, 3 zeros and 5. Okay, good. Correct. The coordinates here are 0 and 5. Okay, so the first thing we're going to talk about is, why is it 5? Okay, why is it 0 and 5? Basically, because that statement is telling us, since it's a reflection, okay, it's telling us that A and C are basically the same distance from the x-axis. Sorry, I keep saying axis. From the symmetry of axis, the axis of symmetry. So this line is equal to that line. Okay, that's why it's saying it's a reflection about it. Okay, as well as it's along a horizontal line. Okay, because they have to be in line in order for one to be a reflection about the other. Remember, you take a mirror reflection. Okay, so in that case, they are definitely going to be in line. So A and C, if you had to fold this in half, it's just like a page on a page and fold it together, A and C would be touching each other. Okay, and again, yes, it says it's equidistant apart. It's not going to help us specifically in this case, because it would help us to get the x coordinate, but we know that the x coordinate of C is definitely 0, because this is where it cuts the y-axis. Okay, you can see that this point here, okay, has had no horizontal motion from the y-axis. Basically, it hasn't moved left or it hasn't moved right. Since it hasn't moved left or it hasn't moved right, its x value cannot be like past 0 on the right or past 0 on the left. So in that case, we know it's x0. I mean, its x coordinate is 0. Why is it 5? Okay, remember we discussed on a horizontal line, the y coordinate remains constant. Okay. So C's coordinates are 0 and 5. Write down the equation of the axis of symmetry of F. Write down the equation of the axis of symmetry for F. Okay, so here is where the second thing that we did comes in clutch. Okay, so the equation of the axis of symmetry, firstly, it's B. B creates this equation of axis of symmetry. Now, the equation of axis of symmetry is the equation of a vertical line. Okay, remember the general formula is that x is equal to the x-intercept. Okay, alternatively, x is equal to whatever x value is on that line. Okay, x is equal to whatever x value is on that line, because the x values remain constant on a vertical line. Okay, that's crucial for you to remember. Can C be seen as the y-intercept? Yes, definitely. Okay. However, it is definitely the y-intercept. Okay. However, it's not like because C is in the formula that now every variable for C that you see. Okay. Wow. No pun intended. Every variable for C that you have doesn't mean that that's the y-intercept. It's just a coincidence that this point is labeled C, and in the equation it's also C. Okay. Right. Let's move on. So yes, when we talk about the equation, x is equal to the x-intercept or any x value on that line. So basically, obviously here, we're not going to be able to get the x-intercept, right? However, we can get the x value of the turning point. Okay. Now, how are we going to do that? We are going to do that by using the other important thing that we learned. Okay. Again, these are all small things that seem simple, that seem easy when you do them separately. When you learn each concept separately, it's almost like Euclidean. When you learn each separate concept, when you learn each concept separately, it's easy. Then when they give you 500 circles and 700 lines, that's when it becomes challenging, right? So again, you need to remember these things. Axis of symmetry is the XTP. That's the first thing. Okay, so if we didn't know that, we wouldn't be able to answer the first question to get the coordinates of C. knowing that it's a reflection about this line, okay? Knowing that it's the image on the other side, all right? Or if we didn't know this, if we didn't know that the x turning point is actually the midpoint of the x-intercepts. So in that case, we can get the equation of the axis of symmetry because we need the x coordinate of turning point. We need xdp, all right? So how do we get that? We have, actually, so in this case, we don't have the x turning points, x-intercepts. However, okay, so in this case, we don't have the x-intercepts, right? Interesting. So normally we'd say x-intercept 1 plus x-intercept 2 divided by 2 is equal to xdp, right? Midpoint of the intercepts. However, we don't need to, because in this specific case, right, these two are in line, because remember C and A are reflection about the axis of symmetry. So C and A are a reflection about the axis of symmetry. So basically, it's almost like these two are, because they are connected on a horizontal line. It's almost like they are the x-intercepts, and we have 2 points which are, if we want to say, the exact same distance from turning point. So in this way, so from here to here and from there to there, it's the exact same thing. So therefore, we know that that's the midpoint. Okay, due to the same statement that they said that it's the reflection about the axis of symmetry. So in this case, what we could utilize is midpoint of this guy. So it's basically going to be -4 plus 0/2. It's going to be -2. So we know that the x turning point is equal to -2. So firstly -2 and then ytp, whatever the coordinate for the ytp is. Okay, we obviously don't have an equation here yet, so we can't get that. However, we can write an equation for the axis of symmetry. An equation for the axis of symmetry is going to be x is equal to whatever x value is on that line. So x is going to be equal to, we just solved for it. What is it? -2. Okay. Okay, cool. So do you guys have any questions? Okay, does that make sense? Is someone confused about anything? Okay, I'll be a lot more open to talking to you guys, just because it's less people. All right, like just interacting, making sure you guys understand. It's a lot easier with less people. Okay, so again, please feel free to ask your questions in these sessions. Yeah, so starting off functions on Saturday, we will start the functions again. We'll go through the basics, right? So it'll sort of be a revision for you guys. But yeah, like these type of questions, obviously we'll tackle them as soon as we done parabola and straight line or whatever, then we'll do a parabola straight line question. As soon as we done like exponential, we'll do like an exponential question. If we done early in the next session, because obviously we have 2 extra sessions a week, so if in the one section we done early, we do another question in the next session. Maybe you guys will have questions. Maybe we can continue to do exponential, parabola, blah blah, and we move on. Right? We can make it however we can go at a faster pace if we keep finishing, because we have extra time. Okay, cool. It doesn't seem like anyone has any questions. I think there might be a delay in today's Zoom and chat for some reason, but it's fine. Yeah, if you guys don't have any questions, then we can end it there. I will see you guys on Saturday. Okay, and hopefully some of you again on Saturday and maybe again on Wednesday. Okay, I'll just leave it open for a few minutes. If anyone has any questions, then they can ask. F1. Will you be doing trig? Still yet to send the timetable, but yeah, I think we will be doing trig this time. No problem. You're welcome. I think everyone, you guys are probably busy with trig, so we're going to try and get functions done. So yeah, again, we can also start with trig. All right. Okay, cool. So let's end it there. I will see you guys on Saturday. Hopefully, have a good rest of your week. Enjoy school. All the best. Thank you guys so much for joining.